Hey team, during this lesson we will be using the addition formulae, the ones that we learned about in the previous lesson. If you haven't done the previous lesson yet, you need to go back and do that one. Okay, this is chapter 7, lesson 2, and we are going to be using the addition formulae. Now, the addition formulae, sometimes called the compound angles formulae, are written here. You should have those. Again, look back on the previous lesson if you don't know what those are. If they look alien to you, you're in the wrong place. Go back one lesson. And we've also got the exact values of trigonometric functions. Now these are really important. The exact values of trigonometric functions you can find using your magic triangles. You should know what they are anyway. And also we've got the radian version as well, which again you've seen in school. So we're going to work out the exact value of sine of 15 degrees. Now sine of 15 degrees isn't in here. We don't have a magic triangle that includes 15 degrees. But we could say, well, isn't sine of 15 degrees equal to sine of 45 take away 30? Okay, isn't that true? Well, yeah, it is. 45 take away 30 is 15. The same thing goes if I used 60 and 45, that's absolutely fine, but I've chosen 45 and 30. Now I'm going to treat that as A, treat this as B. Taking a look at my compound angle formula, so when I've got sine with a minus, I've got sine of A cos of B with a minus sine of B cos of A. Okay, well that's going to be sine of 45 cos of 30 minus sine of 30 cos of 45. Okay, well sine 45 is 1 over root 2. Okay, it's non-rationalized. We'll need to rationalize in just a second. Cos of 30 is root 3 over 2. Okay, sine 45 is 1 over root 2. Cos of 30 is root 3 over 2. Minus sine of 30. Well, sine of 30 is a half. Lots of cos of 45. Well, cos of 45 is 1 over root 2. And we'll end up with root 3 over 2 root 2. Take away 1 over 2 root 2, which is going to be negative 1 plus root 3 over 2 root 2. And then we can multiply through to rationalize the denominator by root 2 over root 2. Now normally you could just tap that into your calculator, and you can tap it into your calculator, making sure it's on degrees to double check your answer. The answer that I get out of this would have been negative root 2 plus root 6 over 2 times root 2 times root 2, which is 4. Okay, and really often that's written in that way there because we like to have the negative next. Okay, nice and simple, really nice application for these things. They can seem really alien until you start applying them. Once you start applying them, you'll see what the point of them is, and they're pretty nice to use. Okay, moving on. In this question we've got radians. Okay, we've got 7 pi over 12. Now my suggestion here is that in the radian section you make it so that everything's out of 12ths, rather than making everything into sixths and quarters and thirds and stuff like that. If you make everything into 12ths, it becomes a little bit easier. So you get 2 12ths pi, we'll get 3 12ths pi, we'll get 4 12ths pi, and we'll get 6 12ths pi. Now obviously those would cancel down and whatever else, but when we're looking at this thing and it says it's in 12ths, it's handy to have things being in 12ths because you can use them nicely. So 7 pi over 12 can only be produced using those two. Okay, 3 12ths pi and 4 12ths pi. Okay, so let's have a little crack at them, see what we can do. We've got tan of, well, I'm going to have 3 12ths pi plus 4 12ths pi. Okay, I'm going to call that A and I'm going to call that B. Now those are tan of pi over 4 plus pi over 3. Okay, where again that's A and that's B. It's handy to write those A and B things because when you're going to be using the compound angles formula, you don't want to get confused because they're a bulky formula. Okay, next we've got tan of A plus B is going to equal tan of A plus tan of B over 1 subtract tan A tan B. Okay, now tan of pi over 4 See, a is pi over 4, so tan of pi over 4. Tan of pi over 4 is 1 plus tan of pi over 3. Well, tan of pi over 3 is root 3. So we get 1 plus root 3 over 1 minus 1 lots of root 3, which comes out as 1 plus root 3 over 1 subtract root 3. And normally you could just use your calculator to rationalise that. You can tap it into your calculator and it'll do it in one go, but I'll show you in full how you can rationalise the denominator for it. You'll use the conjugate of the denominator, which is going to be 1 plus root 3 over 1 plus root 3. Remember, if you're multiplying by 1 plus root 3 over 1 plus root 3, you're not changing the value. 1 times 1 is 1, root 3 times root 3 is 4. Is 3, pardon me, but 1 plus 3 is 4. And then we've got root 3 plus root 3 would be 2 root 3 over 1 times 1 is 1. Root 3 times root 3 is 3, but we've got obviously the negative version there because we've got a positive one and we've got a negative one. And so you're going to end up with 1 subtract 3, which is going to be negative 2. Okay, and obviously you get 1 lots of negative root 3 and 1 lots of positive root 3, which disappear. Divide through by negative 2 and you end up with negative 2 minus root 3 and you're done. Okay, again, use your calculator for it just to double check if you want to, but that's how it's done without a calculator. Next, final question, before I move on to giving you something to do yourselves. We don't know cos 40 and we don't know cos 5. Take a look at the structure though. I've got cos, which means I could only be talking about this row here. I've got a minus in there, which means that I'm talking about this row here and I've got a minus in there. Okay, so we've got cos of, well, if this is a minus here, then this must be a plus here. Look carefully again, we've got plus, minus, minus, plus. We'll have the opposite of the sign, okay? And so if this was a minus, we'll have a plus here. And so we're going to have cos of 40 plus 5, just by comparison. That comes out as cos of 45 degrees and cos of 45 degrees. Again, go across in this table and we'll end up with 1 over root 2, which is root 2 over 2 when rationalised. Okay, nice and easy, pretty fun, not overly difficult. Okay, every so often you can be given one of these where it says, you know, it might have like a 1 or a root, or it have some sort of value on there. So for example, if I was working out cos of 50, it might well be made up cos of 50 of cos of 45 plus 5. Okay, and what will happen is you'll get the exact values for that being used within the question. So you'd have, say for instance, you'd have a minus in the middle, but you'd have cos of 45, which is going to be 1 over root 2. So you'd have cos of 5 over root 2 with a minus. Okay, and you'd have sine of 45, which is 1 over root 2. Lots of sine of 5. Okay, which would be sine of 5 over root 2. So you might have something that looks really, really different. Okay, the rule really with that would be that what you should do is you should separate the denominator if one exists. Okay, and then take just a good look at what you've got, and you should really spot it from the table up there. Okay, which is pretty important. All right, your tasks. You've got Edexcel Year 2 book, you know how to get onto it, exercise 7b, pages 172 to 173. The questions I want you to do definitely, and you have to put onto Google Classroom marked for me please, would be 1, 2a, 2d, 2f, 2h, 2l and 4. And as an extension, if you want to do some extra work, then do questions 3 and 5, as well as doing anything missing from question 2 if you want to. Don't try to do the entire exercise, you haven't seen enough just yet to be able to do that. That's coming up on the next lesson. Okay, good luck.